Okay, so the problem given to me for the extra credit video was the summation from k equals 1 to infinity of the natural log of k over the square root of k. Now when you first try to do the nth term test, you find that it is inconclusive, and if you try the ratio root test, you'll also find that it's inconclusive, or that this problem does not work well with the ratio root test. So you go on to one of the comparison tests, and in this case we'll be doing the basic comparison test. And what we'll compare it to is 1 over the square root of k. Now we know that 1 over square root of k diverges based on the p-series, which I'll just show right here quickly. So the summation of k equals 1 to infinity of 1 over the square root of k is also equal to summation k equals 1 infinity 1 over k to the 1/2. And because this p-value up here is less than or equal to 1, it diverges. So we know that this function up here diverges. And for the basic comparison test to work, when we choose a function that diverges, we have to show that this is less than our given function at all points. Now unfortunately 1 over the square root of k is not greater than ln of k, or sorry, less than ln of k over the square root of k at all points. But it is after a certain number. So what we can show is that if part of this diverges, then the whole thing diverges. So first we have to find, okay, where does this become smaller than this at all points? And to do that we find where they intersect. And in that case it intersects when they are equal to each other. So let's go ahead and set these equal to each other. We have ln of k over square root of k equals 1 over the square root of k. Now you can go ahead and simplify that by canceling out the square root of k's. So you're left with ln of k equals 1. Raise both sides to the e. So go ahead and do this. We get the e and the ln cancel out, so we get k equals e to the 1. So we know that at e, these two equations cross over, and 1 over the square root of k becomes smaller than ln of k over the square root of k. So what we're going to do is split this summation up here into two parts. We're going to say the summation from k equals 1 to e of the ln of k over the square root of k plus the summation from k equals e to infinity of ln of k over the square root of k equals this up here. Now all we have to do is show that one of these parts diverge. And we're going to pull this part out because that is the part that we can compare to 1 over the square root of k, because this is less than that at all points. So if we know that the summation of k equals infinity, equals e of infinity of 1 over square root of k also diverges, then we know, let's go ahead and write that that is less than the summation of k equals e to infinity of ln of k over the square root of k. If we know this is true, then we know this part diverges. Therefore, this whole summation also diverges. So, in summary, based on the basic comparison test, by comparing to 1 over the square root of k, we know that ln of k, the summation, over square root of k diverges as well.